In this illustration, we are going to study about the potential difference inside and outside of a cylinder. And here the situation is saying that a long solid cylinder of radius r is uniformly charged at volume density rho coulomb per meter cube as shown in figure. And a point charge plus q is fixed at 3r, r by 2. And we are equal to find the work required in rotating the cylinder about z-axis by an angle pi by 2. And we are given to neglect any friction in interaction between point charge and material of cylinder. So here in solution, the situation is saying that about this point, and if I consider this direction outward as z-axis, so if we rotate it by an angle pi by 2, the final situation of cylinder would be this, and the point charge plus q will be at an interior point of the cylinder in final state at a distance r by 2 from its axis, whereas right now it is located at a distance 3r from the axis of cylinder at an exterior point. So here if I wish to calculate the work done in rotating the cylinder from initial to final state, here as being a conservative field, I can calculate work by any method so that final situation remains the same. So here I can write work done in rotation of cylinder will be equal to, here I can write work done in shifting plus q from point A to B, where in the situation I consider this point as point A and point B I consider here, which is at a distance r by 2. This is the point I consider as point B. So if I shift this charge q from this point to this point, the work done will remain same, because in final state the situation of the system is exactly the one in which the point charge plus q is at a distance r by 2 from the axis of cylinder. So no matter whichever way we achieve the final situation in conservative field, the work done remains same. So here we can write it simply the charge multiplied by the potential difference as it is shifting from A to B. We can write it VB minus VA. And here potential difference we can calculate VB minus VA is equals to integration of E dot dr, that will be from point A to B, or it is from B to A, and I take positive sign as I know here due to outward electric field VB is greater than VA. And from point B to the surface, the value of electric field inside the cylinder, we know it is given as rho x by 2 epsilon naught. We already studied in video concepts. And for outer region, we know electric field in the outside region of a cylinder is given as rho r square by 2 epsilon naught x. The same results I use here. That is from r by 2 to r, it will be rho x by 2 epsilon naught dx, plus it is from r to 3r, I use for outer region the electric field to be rho r square by 2 epsilon naught x dx. If I integrate this, you can see we are getting it as x square by 2 on integrating this rho by 4 epsilon naught. On substituting the limits on x square from r by 2 to r, this will be r square minus r square by 4, plus here rho r square by 2 epsilon naught is a constant, and integration of 1 by x will be ln x, and we apply limits from r to 3r. So this will be ln 3r minus ln r, that can be taken as ln 3. So here this will be rho r square, this rho r square by this 1 minus 1 by 4 is 3 by 4, so this 3 by 16 epsilon naught, plus here it is rho r square by 2 epsilon naught. This can be taken as ln 3r minus ln r, that can be written as ln 3. So this will be the answer to this problem.